We've invited Jon along today because I actually saw the work he was doing about 3 months ago, and just saw various posts about Quartex Developer, and eventually cottoned onto it. And I thought, this is one person that has built a language, a parser, a compiler. What he's built, it's an exe, but the product runs inside a web browser for the user. And then I found out the whole thing's actually written in Delphi. So it's, he's built an IDE in Delphi. It's Delphi writing, he's writing an IDE inside an IDE and then deploying that to us. So each one of those is really quite an impressive task. Every single one of those, I thought, wow, someone's written a compiler in Delphi. That would make a really good presentation. So we've got half a dozen big topics there, and I just thought, wow, we've got to get hold of Jon and just get him talking to us and hear what he has to say. So and I then went out and actually got the product, the Quartex product, and I've been playing around with that a bit, and that's been really impressive as well. So what we're going to see today is a mixture of things from Jon, all those things I talk about, compilers and parsers, and keep in mind everything he's seeing was actually built in Delphi, and he's developed another language, which is the thing that you're actually seeing. That's the Quartex product. So yeah, it's really quite an impressive amount of work he's done in a short amount of time. So so Jon, that's about it from me. I will throw it over to you. You can take any amount of time that you like. It's just an open session. We're often here and like 4 or 5 hours down the track, so you can make it short, you can make it long. We'll just keep the meeting going until we basically kill over and collapse.
Yeah. Okay. Everybody can see the screen now?
Yeah.
The screen is visible. Yeah. Good. Okay.
Yes.
So let's see, how do we move there? Okay, so I'm not going to spend too much time on myself. I run the Delphi developer group on Facebook. I also have a couple of other developer groups like, Free Pascal and those kind of things. I work for a medical company in Norway at the moment, DIPS. We're making different types of software that has to do with, hospitals, doctors. There's a whole bunch of sort of a family of software that deals with medical situations. I used to work for Embarcadero. I was SC for Europe, Asia, and Africa. So traveled a little bit around there and held a few presentations and got to know, the team behind Delphi. It was really an awesome couple of years there. And I have a background. I started coding on, the Commodore 64 and Amiga. And the reason I mention that is because that has a huge influence on this project, much more influence than you might think. But we'll sort of try to cover that. And in my spare time, I've sort of gotten involved with, IoT and embedded stuff. I like to tinker and build things. Like, the Raspberry Pi, Odroid, XU4, all of those, type of small computers that you can pick up today. Before this project, I created Smart Mobile Studio, not on my own, of course. We were a small team. So that also brings me up to the compiler thing, because I can't really take credit for the compiler that we use in Quartex, because that's actually written by Eric Range. That's actually a fork of Delphi WebScript. So it's important to give credit where credit is due. And this goes back to sort of a situation we had before, back in 2010. Everybody wanted mobile applications, and I was simply unable to deliver it, right? Delphi didn't have any mobile framework back then. And I started looking around, and I came up with this idea that, maybe if we take Delphi and compile it to JavaScript instead. And everybody was, quite negative, oh, that's never going to work, Delphi is too complex, etc. And then Eric Range sort of jumped up and said, it's actually possible to do that. And Eric maintains the Delphi WebScript system. And then he created sort of a prototype showing that it was possible. And we ended up working together for a year, with Smart Mobile Studio. Smart Mobile Studio was sort of a side project that that the company had. Eventually, we started a separate company, the Smart Company, which is presently selling Smart Mobile Studio. But I left that in, I think it was 2015. Yeah, 2015, something like that. And then I went to work for Embarcadero after a little while. So they're still at it with Smart Mobile Studio. I think I haven't really paid that much attention to it. I'm also an MYP, so I stay in touch with Embarcadero, and I try to follow up on some of the internal cases there. Already covered the Delphi developer and C++ developer groups and stuff like that, and I also do some technical writing for Idera. So not really that much interesting. Let's see. So Quartex Pascal. The idea was more or less the same as Smart Mobile Studio. Smart Mobile Studio takes Delphi code, converts that to JavaScript, and then you have a runtime library behind that, which basically gives you all the classes that Delphi has in the DCL, for example. All of those underlying classes that you need, all that functionality. But as I exited the company, I couldn't really use that code in my own projects anymore. So we came to a point where we simply had to say, okay, fine, I have to roll my own. I have to start from scratch, and that's where Quartex Pascal comes in. So this is a community-funded project. We have a sort of a small group on Facebook that is hidden, where there are a few people that sort of financially back the development. And we have a number of goals. I'm going to cover those goals as we move along. Now, the RTL is sort of where most of the work is happening right now, because in order to support all the different JavaScript technologies, you really need to, there's a lot of work, especially for Node.js. So, but the benefit is that once you have a working system so that you can simply write Pascal in a way that is familiar, you can also, copy and paste over some code from Delphi. And you can compile that to JavaScript, and suddenly you sort of have this platform agnostic system, because JavaScript behaves identical on all platforms. So if you write, for example, a system service, and you're sitting on Windows, you can physically copy that service over to Linux or Mac OS, and it will run and behave identical. So the way that I use JavaScript here is simply as a means to an end. I don't really sit in JavaScript and spend hours, typing all that low-level stuff. For me, that it is simply a medium. So we use that to run the code to provide the functionality that we need. So JavaScript has come of age. I mean, when I started to look at JavaScript, when I was sort of looking for how can I make mobile applications, Delphi didn't have support for mobile applications. My options were, okay, I can go for Objective-C, for example, which to me was simply not an option. It was, I tried, but it was just, oh my God, this is not, I'm used to Delphi, so Objective-C was a terrible experience. And then you had Java, which to me was the exact same thing. And I spent 1 year in C#, and then I started looking around, and I thought, JavaScript has actually come of age. It's completely different from how I remembered, JavaScript back in the 90s. JavaScript was a toy, to create pop-ups and mouse overs and all those old effects. But it has grown into this sort of monster. And the speed has gone through the roof because especially Google has invested a lot of time and money in ensuring that JavaScript will run almost as fast as native code. So the JavaScript is first, converted from text into bytecodes, and the bytecodes is then converted into machine code. So there's a whole infrastructure inside a modern browser today. So you can write some really amazing applications if you do it right. There's a lot of technique involved as well. So the JavaScript that I'm talking about is quite modern. It's not like simple functionality and stuff like that, just to underline. And the benefit is also, like I mentioned in the previous slide, that you get identical behavior. That is really the key. Because if you write one JavaScript application or compile to JavaScript and it will behave differently on all the platforms, then you have a problem, because you can't rely on it. Now, I mentioned system services, and that is something called Node.js. So Node.js is essentially that they took the JavaScript engine, the V8 engine that Google made, and they simply decoupled it completely from the browser, just took it out of the browser, removed anything that had to do with the browser, and then they added a ton of modules that has to do with the file system, calling native packages, DLL files, etc., authentication, all of that stuff, like HTTP connection, TCP socket, the whole stuff that you would expect to find in, for example, Delphi or PHP or Python, or those types of scripting engines. And this has become just amazingly popular. There's something like 1 million packages that you can freely download and use for Node.js. So almost anything you can think about, no matter how complex, somebody has made a package for it, and that is pretty cool. And it's freely available. There's a ton of development going on with it. They also made support for native packages, so they're actually taking the C++ compiler Clang, and they've embedded that into Node.js, so that when you download a native package which is written in C, that will be compiled into Node.js itself. So you get optimal speed when you're using Node.js. And it's asynchronous, which is it means that it's event driven, but it basically divides the CPU time between different functions. So it does most of the work between the calls. Yeah, I'm not going to dig into that. It can get a little bit complex. But yeah, it's turned out to be a wonderful solution for writing, platform agnostic and multi-platform services. If you have, for example, a typical Delphi service, I wrote one for, there was a advertising company. So they were getting like large TIFF files, huge pictures in. And I wrote that in Delphi, and it converted those TIFF files into JPEGs and created a thumbnail. A typical low-level service that requires a little bit of power. And I recreated that service in Node.js, and suddenly we had support for Mac OS and Linux. We can deploy this to the cloud, for example. We didn't have to pay for a full virtual server. It could be hosted by pretty much all the standard hosts that cost $1 a month or something like that. So
Jon,
it opens up. Yeah.
A quick question, if you don't mind. So Node.js would be suitable for replacing PHP type scripts, would it?
Yeah. So
Okay.
PHP and also to some degree Python. Python is a very powerful system, but Node.js has the exact same functionality and also a little bit more. So people use this to create, for example, their own web servers, integrated websites. You can almost compare it to IntraWeb. Of course, they don't have a visual designer for it, but it's kind of the same functionality, with the benefit of being cross-platform, and you can just copy the JS file anywhere. So yeah, that is Node.js. So that is sort of the one part of the deal, being able to cover Node.js, to have a RTL that covers these classes so that you can use the built-in modules, and also I've converted a few modules like SQLite, also hoping to convert database modules, for example, for Microsoft SQL, MySQL, and those types of databases. And then you can have write database-driven backends that are completely platform independent. So Quartex Pascal is essentially trying to not shape JavaScript to live by, the Delphi rules, if you like, but trying to create a cool blend where you get all the benefits of Object Pascal, and then sort of marry that with, the flamboyance of JavaScript and create some exciting new technologies. So if you know Object Pascal, then you can sort of tap into this new marketplace that has been completely sort of ignored by Embarcadero and some of the other companies. So that is sort of the purpose of Quartex Pascal, to provide a path for Delphi developers to tap into this market. So the IDE is a little bit Spartan. it's not as cool as Delphi yet. The writing in IDE is actually sort of a never-ending project, because you're never happy. You always want to add something more, just a little bit more. And if you're not careful, you can end up doing this for 15 years without any problems. But I think we have gotten sort of a good foundation. We're still working on it. It's nowhere near complete. But we have things like a form designer that is coming in now. We have the RTL classes, simple functions that we don't really think about, like open file at cursor and control click on a symbol, for example. Those things, it takes time, and you have to have a background compiler and parser that does a lot of this. So this system actually contains 3 compilers. You have the Delphi web script, or the fork of Delphi web script. I've adapted it quite heavily. That takes the Object Pascal code and converts that to JavaScript. So that's one of them. Then you have another compiler that I've written, which is called LDEF, which is a bytecode compiler. So eventually we will be able to compile all of this to bytecodes, and then you can further refine that into machine code. Sort of the same path that .NET has gone. And then the third one is a full JavaScript engine written in Delphi called Besen, or Besen. I'm not sure how you pronounce it. It's a German word. So that takes care of parsing. For example, if you double click on a JavaScript file on the left there, then Besen will parse that file and show the symbols for the JavaScript syntax on the right. So you sort of get a unit overview, much like Delphi, but also for JavaScript. So the project types we have so far, we have more project types coming in. We have Node.js applications, like you can see on the top there. So I've covered, the most typical scenarios, like, okay, you have a shell application that also doubles as a system service. I'm gonna show you how you would create a system service in Node. HTTP server, UDP, WebSocket. There's also a TCP socket project, but I haven't registered that yet. The visual applications, those that are supposed to run in the browser, we have a lot of more options there. So it's actually a bit difficult to try to pin down the difference in layout, for example. So dynamic is top-down standard website. So the forms that you create, let's say you have 5 forms in your applications, those 5 forms will be sort of stacked on top of each other. And then you have methods like go to form, and then it will scroll down to the form that you select. So you can create these cool dynamic websites. A tabbed dynamic is sort of the same thing, except that you have a tab control that covers the entire visible view, and then you can tab between different pages. So you can use that to create, for example, if you hide the tab bar, and then you can control the flow of the application. It's good for creating wizards and registration forms, those types of applications. The next application is the windowed application. So we actually have a full window manager that we're implementing now, so that you can have windows that you can drag around and maximize and minimize, etc. And then the final application model is for mobile. And that's when you have forms that cover the entire visible display. You can swipe left and right if you enable that. If you move between forms, they slide. You have some cool effects, just like iPhone, basically. And that is, I think with those type of applications will then be more than enough. That, you know, we sort of cover the basics then. This is also template based, just like Delphi. When you create a new project in Delphi, it actually simply duplicates the template that it has. So somebody has just, you know, created sort of a startup project, registered that as a template, and then that is cloned out when you create a new Delphi project. And this is the same thing as well. So you can right click on this and you can go in and you can edit the template and copy it, for example. So you have a lot of freedom. You can register as many project types as you like. If you come up with something that is unique to your company or some cool thing that you've made, it's just an ini file to register a new project type. And I probably don't have to cover why Object Pascal in the Delphi group, but people have asked me, why on earth have you gone with Object Pascal? Why not TypeScript or, you know, Java or C# or something like that? And the obvious reply is because we can. it's you know, I love Delphi, so yeah, I want to make Object Pascal available, especially for teenagers who want to learn the language for free. I want them to have full access. So this is going to be completely free for everybody. Everybody can download it and use it. We only have one clause, and that is that if you're going to use this to create, you know, professional applications, and you want to go in and change, you know, the RTL and the code base, then we would really appreciate that you pay a commercial license. But that license will never cost more than $300, and that is a lifetime license. So this is not a financial venture. This is a passion project. I really want students to have, you know, full access to being able to write web applications and mobile application. It shouldn't cost $5,000 to be able to do that. That is ridiculous. So this is my personal little protest against some of the pricing that's you know, dominating the Delphi community. And besides, you know, the Object Pascal is easy to learn, especially when it comes to classes. I mean, if you look at JavaScript and how they have implemented classes, it is absolutely horrible. They have based it on something called prototypes, which basically means that whenever you create a new instance of a class, you're cloning hundreds of properties. A JavaScript object is the same as a JSON object. So if you ever work with JSON, then those are the type of objects that JavaScript deals with. So there's a lot of overhead. So one of the brilliant things that Eric did with the CodeGen, I'm sorry, Eric did with the CodeGen for Delphi WebScript was to implement a VMT-based system in JavaScript. So when you create a new instance, you're only sort of cloning out the fields part, you know, the data part of the class. So it's very efficient. Sometimes it's even more efficient than some of the frameworks that's written in JavaScript. So this is not a financial venture. This is pure passion. Yeah. So I hope that people will enjoy that. I've been contacted by some schools in India that was, you know, super interested in getting this system, and also the desktop part of the system. I'll cover that later. So the desktop system is probably the most curious thing, and in order to understand, you know, the reason for it, I have to sort of tap into one of my hobbies. I mentioned initially that I grew up with, you know, Commodore 64 and the Commodore Amiga, and I absolutely love those machines. I still tinker with them, and there's a whole community of people that just, you know, love Amiga machines. But one of the tragedies of that computer system is that the hardware never failed. It wasn't the product that failed, it was management. And the IP for that system is still locked up in lawsuits. They're still fighting over who owns what. They've been doing this now for 20 years. It's sort of the archetypical example of how bad things can go if you don't manage your IP. So different companies owns different parts, and that's why the Amiga, just vanished, in the mid 90s. It just, suddenly it dropped off the planet. And I started thinking, would it be possible to re-implement something like, the Amiga desktop? Because the desktop and the operating system was extremely efficient. This was a system that was designed to run in 0.5 MB of memory, and it ran rings around, the early Windows and those types of things. Is it something in that technology that we can sort of learn from and bring with us? See if we can do something new with it now. I mean, today you can pick up a $99 single board computer like a Raspberry Pi, for example, or something a little bit more powerful like an Odroid. And that little device has more power than 100 of those Amiga machines used to have. So some of the ideas that were implemented for that old system, but never really sort of worked because they didn't have the CPU power. So I thought, okay, let's see if we can learn something from this and see if we can implement, take the Amiga ideas, try to recreate them and create a sort of a cloud platform so that you have background services written in Node.js that are portable. You can copy them between, Linux and Windows and whatnot, and then have a visual desktop that sort of talks to these background services. A little bit like the Amiga had, custom chips that, one chip that did the graphics, one that did the music, and sort of an early GPU type thing. So I started on little hardware projects. So these are the clusters that I have sort of running in my home. I built this from scratch. So this is a Pico 5 case. I'm not going to take credit for the case. I bought the case. And that houses 5 Odroid XU4s. Those are a little bit more powerful than a Raspberry Pi. So the idea was then, okay, I'm going to create different services so that one of these will run, for example, the authentication system, allowing for login, normal Kerberos stuff. And then I will have another one that deals with the file system, and another one that deals with, for example, running an emulation session. I can sort of divide the work between these. And if I need more power, I can just plug in another computer into the switch that you see on the side here, and that will become sort of part of the hive. So now suddenly we have entered into cluster computing. And I did actually try to do this in Delphi. You can, of course, create sort of different services and make them talk to each other, but a native language really is not suitable for high-end clustering, not the way that modern clustering is done. A script, for example, is able to generate its own code in order to solve a problem and physically send that code to one of the SBCs and execute. You can't do that with a native system. You would break every security rule known to man, and it will also be very slow. So the reason I mentioned Amiga was, of course, like, trying to learn something here. So JavaScript is asynchronous. Now, asynchronous is more or less the modern version of preemptive multitasking, as we used to call it back in the 90s. So the Amiga was the first system to actually use preemptive multitasking. And of course, since JavaScript is async, those two match up. So you have the exact same philosophy and the exact same runtime behavior. So that's why I'm sort of going on about the Amiga. Yeah, I kind of covered this, sort of talked ahead a little bit. Yeah, divide work into separate services, etc. And then you can host those on different mini computers. I should mention that you can also host them on a single computer. There's no law that says that you need 5 computers in order to run this system. You can stuff them all into one system. You can run them on a Windows computer. You can run them on a Linux computer. I'm using Linux on these tiny devices. You can buy a single board and put the whole thing in there. Yeah, so I kind of covered this as well. So what I do when this system boots up, I guess I can mention that as well. When this system boots up, it starts, the normal Linux stuff. But instead of going into the Linux desktop, the X windowing system, I start Chromium in full screen, in kiosk mode, as it's called, in full screen, in its own session. And then it loads the desktop. And so the impression is exactly the same as starting a Windows, starting Linux. There's no difference, except that the entire desktop is written in QTX and Smart, and it's JavaScript. You can also connect to the services or connect to this cluster using a normal web browser. So it's perfect for creating routers, for example. If you have a company like Jensen contacted me about it because they have a lot of cheap routers. You can get a router for $50 or something, and the user interface part, when you connect to the router to do some settings, the user interface is just terrible. And for them to being able to simply copy and paste this system into the router, create a nice looking interface, that is of course gold for them. So the desktop system can be just an environment for your application. If you have, let's say you have an accounting system and you want that to make that available using a browser, so that your customers can log in, they can start the accounting system. You can use this system then to as a sort of a foundation, as an ecosystem for your own applications. And it doesn't matter if you have your accounting system implemented in Delphi, for example, as long as it's implemented as a service. And then you can simply use this to display it. So this is a snapshot of the browser. I'm going to show you it live as well. We can look a little bit behind the scenes. This has the same look and feel right now as Ubuntu, I guess. The only difference is that on top left here you have the same menu system as from the Macintosh. The Amiga had a similar system, so you click and you get an application menu. So there's a global application menu involved. You can also mount up devices. Here we have like the RAM disk, which is an in-memory file system, and the entire file system is implemented in Object Pascal and compiled to JavaScript. Then you have a user disk, which is basically a mapped folder on the server. Again, the file system is implemented in Object Pascal. You have icon services. So the pictures you see here, the icons, are actual Amiga icons with 24-bit graphics. But you can use, you can take a normal picture like a PNG and just, copy it over. But I thought it would be cool to actually support that old file format as well. You also have ICO and GIF. So here we're running Photopea, which is a quite famous web application. It's sort of a Photoshop clone. And this is running inside its own window. It has its own iframe, and that frame communicates with the desktop using messages, just like Windows does. So it has to send messages in order to, tell the desktop, and vice versa. And you have an icon dock on the right, which I guess is a little bit Ubuntu-ish. I've sort of gotten used to it, so I thought it would be a good idea. But you can hide all of this, and in the settings file, you can disable pretty much anything. You can disable the menu, you can disable the drives, you can disable this, and then you can simply use it as a sort of a ramp for your own visual web applications. So I'm trying to do for JavaScript and web applications what Windows did for native applications. So you have an SDK. You can call methods like open window, open file dialog, and you get modal dialogues. You have a whole API there that you can use from your web applications, running isolated inside the frame. So I guess we can have a little look at, this is just a video. I recorded this without sound. So you can see you have pretty much, the same behavior that you would expect from a normal desktop. You can double click on folders, etc. You can start applications. And this then runs as a separate, completely separate instance inside the frame. So the code that you have running inside here can't, jump out and do something else. It can't, take over your desktop or anything. There's quite rigid security context that is applied to each of these frames. Yeah, and of course, no desktop is complete without running Quake or Doom. So that was one of the first thing I added. So this is compiled from C++ to JavaScript. Well, it's actually Asm.js, which is a precursor to WebAssembly. And it runs pretty well. You get 60 frames per second. That is the maximum frame rate for the browser. And this is running on $100 hardware. So it's if you run it on an i7, it will be really smooth. And we have a music application. This is a classical tracker application. Those type of music applications were quite popular back in the 90s, so it felt right to include that. So the reason I'm testing with, you're probably thinking, why on earth are you, playing games? I'm not playing games. This is if this system is capable of running Quake at 60 frames or something like that. Actually, I'm lying. This is 45 frames. It is more than capable of running a desktop application. So this is extremely demanding running applications like that, games and multimedia. So being able to handle an invoicing application or something that you would, a typical Delphi application is a piece of cake once it actually manages this. So I felt it was a pretty good test. Yeah, this is actually one of the first demos that I ever saw on the Amiga. I'm just going to pause this. Now we get into the third compiler that I mentioned, the bytecode compiler, LDEF. This is a small application I made, which is a copy of an old assembler program called Asm1. But WebAssembly is extremely tedious to write. Nobody hand writes WebAssembly. That is just, it's designed for machine generating. So I had to come up with something fun. Okay, what kind of syntax can we do? I want to have a full tool chain. I want to have the assembler. I want to have the high level languages. The complete tool chain. So okay, let's create an assembler standard. So I based this on the old 68K assembler. So here's the code. You can see that it looks very much like 68K. The only difference is that you're working with you have variables as well as CPU registers. And this is a whole lot easier to convert this into real machine code. So you can assemble it. Here's the bytecodes after you have assembled it. Here's the disassembly. You can see it has calculated the jump offsets correctly, etc. So it's all relative. So yeah. Let's see, how do I move away from this? Oh yeah, there we go. Yeah. Okay, so I'm going to show you a little behind the scenes. So we can put the Amiga aspect sort of on ice. Again, I'm using the Amiga as trying to learn from it. It's not just about recreating the Amiga, although that is a worthy goal. It has more to do with learning from the technology. Some of the ideas that existed in that system has been completely forgotten and neglected, but they actually make more sense today in a cloud environment than they did on those old machines. So that's kind of the purpose there. So I can show you some of this. Is pretty low level still because the visual designer is not completely ready. We can have a little look at it. So here's the designer, but it isn't hooked up yet. So I have to sort of marry the visual design with the code units. So whatever you make here, when you can drag and drop buttons and panels and everything you're kind of used to in Delphi, that will be generated into code and then injected into your Pascal file. But this will happen during compile time, so it won't mess up your unit code or anything like that. It will support both layout modes. This is absolute positioning like we have in Delphi, so you can drag things around. But it will also support blocking mode. In blocking mode, all elements, all containers stretch to 100%. So it's perfect for making an application that should fit all devices. So the width will always be 100%, and then you can sort of have a variable height. And then you can put another panel in there, put another panel, etc. You can build up sort of these display blocks. And that is also extremely fast to calculate and do layout with. Let's see. Yeah, so we can build and compile and run. And here we have a sort of visual application thing. So you have windows, you can put them in maximize. You have set order control, which is actually really tricky to get working on the JavaScript, because JavaScript operates with something called stacking context, which means that the set order for the control is the same as when it was created. So the first one will be the first, and then the second, like a deck of cards, and then you have to sort of work with the whole stacking context. But I found an elegant way of dealing with that, so it's really fast. The content can be swapped out with anything you want. You can run your own application. You can take a QTX application that you made, for example, and run that inside a window. So you can build up a lot of functionality really quick. You can put it in full screen. And also this is theme-based. So the look you see here, which is kind of a little bit childish, it's based on Ubuntu and the old Amiga system, that is optional. You don't have to use that at all. I think that a lot of people will probably prefer something that looks a little bit more window-ish or Apple-ish or something like that. But we're going to have multiple themes. You have menu systems. Yeah, so I'm sort of building up all the functionality that we're used to having in Windows. And new project, here's the project system, like I mentioned. Yesterday, we added support for theme files. So you can pick a theme. We just have the default theme right now, but at least we have set a standard for how theme files can be created. They're normal CSS files, and there's some simple rules for the CSS styling. So a CSS class will always map to a Pascal class of the same name. So if you have a class called tButton, then you can create a style class called tButton, and those will match up automatically, which is pretty handy. And like I mentioned, you can support, there's different types of applications. You can write services and servers. We can have a little look at, let's see, what is a good example? Yeah, I have to run 2 instances then, but yeah. So this is a standard project for WebSocket. Creates a server instance, then you set up some events on client connected, on text message, because WebSocket can handle 2 different types of messages. You have binary messages and text messages, so it's just an event. And then how you treat that message, this is just a text message, a string. You can use whatever you like. In this case, I'm just sending a string called send file, and then the server returns a PNG image back to the browser. So you're able to write both the server aspect and the client aspect using the same IDE and the same compiler system. And we also have a lot of interesting tools. Ironwood was a commercial product until 2018, I think I pulled it. This is a license management system. So if you have an application and you want to have serial numbers for that application, I think something like this should have been in Delphi a long time ago, so that you can create serial numbers easily for your application, and you have mechanisms inside the application that will sort of check that the serial number matches and things like that. So to create your own serial number system, you could, for example, you can create a WebSocket server. You can use the the Ironwood classes, and then generate licenses on the fly, store that in a database with the user, etc., etc. So you can start building up. So this is for generating serial numbers, and this was a really tricky thing to do because you have sort of a base key that you see here, these numbers, and then from that base key you have to generate X amount of completely unique combinations, and those combinations has to be mathematically possible to trace back to the original key. So that was a little bit tricky to figure out. But so far, nobody has been able to break the key gen or the components. There was one crack in all the years that I sold this system. There was one crack, and they must have spent weeks on it. They actually disassembled the entire application, and then went in and sort of used machine code and then sort of snipped away all the events, which is extremely time consuming. So I was almost like, yeah, well done that you actually took the time to crack that system, because that must have taken a really long time. But yeah, so there's a lot of cool tools that we can create here for dealing with licenses. For example, let's say you have written a invoicing system. Just to take an example, and you're using the desktop as sort of the visual platform. You can issue serial numbers. You can keep track of, this user has paid for 1 year usage, for example. You can sort of use that key to connect up to the storage. How much storage does the user have, etc. So it simplifies creating large-scale applications when you sort of look at the entire toolkit. And you have the runtime library here, so there's quite a bit of units and visual controls that has been created. And even different services as well. I mentioned that the desktop environment has to do with creating the same sort of ecosystem that Windows has for native applications. Except that we're doing it for JavaScript. So things like file system service. There's no such thing as a file system in JavaScript, but we can do that here. So we have standard APIs, standard methods that you can use to then connect to the file system on the server, request files, do things like that. All the missing pieces that you don't get with all of those fancy frameworks. JavaScript, the biggest problem for JavaScript is that there's a new framework every day. I tend to prefer something that's a little bit more stable. But yeah, the whole system is written in Delphi. So we have that here, and there's quite a bit of code. So everything is based on Delphi. So do please interrupt me if there's something that you want to see or something that you're wondering about. I can also switch over. I have another virtual
Jon,
machine
I'd really like
here.
to see like building just a basic hello world. If you demonstrate that, just to people.
Yeah.
I'm not sure they get the concept of it's an idea that's very much like Delphi and the code's like Delphi, and yeah, just something very simple like that.
Yeah, that's a great idea. Yeah. Just have to start it again. I'm in a VMware machine, so it's a little bit slow. Oh, come on. Oh, I should have started it directly from the shell. There we go. So we can have a new project. So we're just going to do a visual application then. I'll take that as yes. Yeah.
I wouldn't mind seeing, John, if you could show us a shell application as well after this.
Yeah, sure. Yeah, but I guess we can start with a dynamic one. So create that. Now, on the side here, this isn't exactly like Delphi, because it doesn't really make sense to have, like this strict tree view that Delphi has. Because in JavaScript, you work with a lot more files. There's a lot more media. So you don't really link in pictures and things like that. So it makes more sense to have sort of a file browser here. And it's of course optional. If you want to keep your forms inside the form, you can create new folders, etc., and manage your files like you want. The starting point for the application is simply app entry points. There's no specific reason for that, except that you have to have a program file in Pascal, and I've called that. And we can remove this, I think. So here we simply, this is the first object that is created, TQTX DOM application. And you have different versions of this. This is why you have different application models. So application full, that simply means that you have access to the complete document object model. This is a complete top-down web page, basically. So we create that. That is a singleton. Therefore, we don't need to assign that to a variable or a field or something. Then we go directly into the document object model. This is a trick. You don't really have to do it like that, but this is faster. Then we simply set the font. Probably a good idea to replace that with something that uses the class. And then we simply create form 1, which is in here. So this is a normal form class. Yeah, let's see. I can probably, I have to explain this. So the only difference between traditional object Pascal and the QTX flavor is that JavaScript is asynchronous. And that means that you cannot force JavaScript to behave like Delphi in every situation. That is simply, we tried that. That was one of the big problems that the big challenges that we had with when I was a part of the Smart Mobile Studio team. We tried to force JavaScript to behave exactly like Delphi did, and we came up with a solution that was pretty good, I guess, but it wasn't optimal. Because when you create an object in JavaScript, that object isn't created immediately. It's created sort of after the constructor finishes. So you have a constructor, the constructor runs, everything is fine, but the object will not exist until after that, the constructor method is finished. And that is a bit of a problem because everything is async in JavaScript. So the object is still being, it's still being created. Properties are written, etc., and you can really risk messing things up, and it becomes unreliable. So the only way to solve this is to have a callback, a separate procedure that sort of calls you back and say, okay, now the object is finished. Now you can start using things, and that is why you suddenly see that we have an anonymous procedure here as a parameter. So for example, this is basically the hello world that you wanted, so there's no point in adding too much to it. But here we create the panel, we pass along the parent. This is just like normal Delphi, but you have to provide this one if you want to sort of set properties immediately and stuff like that. You can, of course, just put nil in there. You don't have to. If you don't have anything to add, there's nothing that you want to create as a part of the construction of that object. You can simply pass nil, and it will still be created. But if you want to be notified when this object has been created successfully, it is now available in the document object model, then you simply provide this anonymous procedure. And that ships in then the instance that is ready to use. So inside here, you cannot access this one because this hasn't been populated yet. This is being called as part of that constructor. So you have to then access through the panel. But again, this is optional. If you don't want to tweak anything, you don't want to set it like the font, you don't want to do something about the position mode or the display mode of the element, then you can just pass nil and continue like normal. But this one has been a source of confusion for quite a few people. That yeah, we're not used to working like this. But I figured this is a small price to pay for concurrency. Being able to rely on your code, knowing exactly when an element is ready for use. The alternative is kind of what we had issues with in the past, that we try to treat JavaScript like Delphi, and you end up having this sort of ghost in the shell, sort of weird exceptions without any clear no clear explanation to why did that crash there, it didn't crash there, and you end up sort of an eternal bug hunt. And it all comes down to basically being able to work with async code. But this is more or less everything you need to do.
John.
Yeah.
Just from a personal point of view, that was one thing that I found a little. It took a while to get my head around this whole async thing, but it does make sense eventually. When you actually start, thinking more in a JavaScript sort of world, I guess.
Yeah.
It does make sense.
It does take a while, but I think this was the quickest way of solving it.
Yeah.
The alternative would be to drop this completely, and then you would have to override the object ready method. There is an object ready method that you can override. All the visual classes has an object ready method, which is called, and then that again calls, like the styling and sets up, the visual stuff. So between those two, having to override in every single visual component you want to keep track of, I figured this would be the most productive way of doing it. And it also taps into how JavaScript expects you to write code.
Yeah.
For example, okay, we create a panel here. Then we can actually create all the child elements as well inside the constructor. So this creates, a really dense code block, and the browser will simply optimize this like crazy. So it executes really fast. And one of the tests we did earlier was, I don't want to speak bad of other products, but we tested things like the Free Pascal compiler, or the Free Pascal framework, and also Smart, and also a couple of other things that were JavaScript based, to see if take something simple like populating a list box. That should be really fast, right? I mean, 20,000 items into a list box should just spin through. But it turned out I had really huge problems, even though I created that part of Smart Mobile Studio, and so I'm the one to blame for that. But I couldn't get more than a couple of hundred. Actually, I think I got 50. Yeah, 50 items or something like that in 2 seconds. It took 2 seconds to populate the list box with 50 items, and I was like, this can't be. It has to be a better way. Then I tested, the Free Pascal stuff, and that was a little bit faster. I think that has something like 1,000 list items in 2 seconds. And then I ran some tests on this technique, and we had 20,000 items in 2 seconds. So So there's a reason that I've sort of stuck with this, because this creates the fastest code. This creates code that can compete with, some of the high-end frameworks. The only thing that I've seen that is faster than this is the Google framework, which is written, in raw JavaScript. That is the only thing that is faster. So yeah, I think it's worth, keeping it. So yeah. So it's not exactly hello world, but you recognize, the label and the text there. We can also make it, simpler. But yeah, I think you get the idea. And another thing that's cool is that you can go in here, for example, into the HTML directly. Like that. So it's pretty non-intrusive. You can sort of write modules in QTX, for example, in much the same way that you maybe did with Flash back in the day. Okay, so you write a cool application. It can be an advertising. It can be a full-scale application. And then you can sort of inject that into your existing web infrastructure, depending on what you have. So there's a lot of cool options there. So let's have a look at the other one. Yeah, we can shell application. I'm just going to create a new one. Same thing here, app entry point, app body. So in Delphi, all applications have, sorry? No. In Delphi, all applications have an application object. We don't really think about that in Delphi. It's the first object that the program creates, and then all the forms and resources are sort of tied into that application object. And that happens in the background. We don't really think about that in Delphi. In QTX, it's a little bit more central. It's still the same system. The application object is created first, and then that is then used to sort of invoke the rest of the application. And this is why you see we have two units here. This one simply creates the node application, and then you have this one sort of in a separate unit. We could have put it in probably in the same file, but I thought it was a good idea to separate them. By default, this one sets up a simple HTTP server. We don't really need that, but we can just execute that and have a look. So HTTP is built in. That's one of the modules that Node.js sort of have linked into itself. So there's a ton of different modules for Node.js that is sort of included in the package. And those are really high performance. They're written in C and assembly as well in some cases, and just linked in. So HTTP is there. It costs nothing. There's no you don't have to include a ton of libraries or external files or something like that. It's included on Node.js in every single instance. We can sort of drop that right line. Hello world. I don't have a read line, so it'll probably just there we go. There's the output. Hello world. So let's have a look at, here you see a couple of the modules, the HTTP module. So here's the wrapper unit for that. Again, we see some syntax that people are probably not too familiar with. That's going to be explained more in depth when it comes to the documentation, so that people can learn different parts. So you're able to, if there are objects that are sort of exist in the runtime, So in the browser, the runtime will be, the document object model and, all the classes and objects that are provided by the browser. In Node.js, those pre-existing objects would be things like, the HTTP module, for example, that exists in Node.js from the start. So we can reference those using a class external. You can also reference them by name. So if I know that Node.js has a module called test, for example, just to take an example, I could do like this. And then I will simply define the Pascal versions of the methods that are in that object. And then I can simply start using it. It will automatically find the original object when you execute this in JavaScript. So it's actually extremely simple and elegant to wrap existing frameworks. And you can also do the same with sort of optional frameworks that you have to download and install, like the WebSocket library or SQLite, for example. You have to install those using the Node package manager.
Hey, John?
Yeah?
We're going to need a break here for about 5 minutes, just whenever a good time for you. We just need to move some tables around. It's stinking hot here, and we're going to try and move some tables.
Yeah, sure. When should we be back?
It'll only be 5 minutes. We just have to move some tables, but we might lose the connection. So if that happens, I'll have to come back in again. So
yeah, no problem. Yeah.
So yeah, we can either take a break or you can just take a question period for 5 minutes, and I'll let you know when we're back.
Yeah.
Okay. So is now a good time for that, or do you want to you get a more appropriate time to take a break?
No, it's fine by me. It's fine by me.
John?
Yeah.
You were talking about the whole async thing with JavaScript and that. Is that something you've had to figure out for yourself right now, or it's something you've dealt with in the past?
Well, I worked for many years with, the Smart Mobile Studio thing. So some of the insight into this, of course, came. We sort of learned that the hard way. That something how it worked. But with QTX, I sort of started with a clean slate, completely from scratch, and that's when I started to look at how does the V8 engine, for example, the JavaScript engine, how does that optimize code? Because we've all seen, these amazing JavaScript demos that run, incredibly fast. How do they do that? So I started looking at the different techniques. So the callback system was something that came out of that investigation. So that is something that I've sort of picked up when I started on the QTX. I had a short period of time when I did some more investigation, and I came up with this.
That was my next question. Was it sort of an arcane digging process?
Yeah, I had to dig around. Yeah, run different tests. I started to look at, okay, why. I created some foundation classes. Okay, how is the fastest possible way to create an element by code? Because all the visual stuff that you see in QTX are created by code. There's no HTML. You don't go in and write the HTML and then simply sort of latch onto those HTML tags. Everything is created from code. So how can I create this as fast as possible? I read everything I came over. I did a lot of tests, and then I realized that, okay, JavaScript actually performs better when you sort of daisy chain these callbacks. That's when it can optimize the best.
Thank you. Also reminds, I think one of our other members was asking about shell code or something.
What? Asking about?
Was it shell?
Shell, yeah. Yeah, I just ran, the shell application. So let's see, shell applications.
Oh, sorry, we were.
Yeah.
There's a little hubbub here.
Yeah, no problems. Well, we can sort of run it again. I think I have taken HTTP server, so you can see that it works. Server example. I think this is pretty okay. And then I need to find a browse. Do I have it? No, wait. Yeah, I can. While I run, this is running inside VMware. So let's see. No, sorry. That was 1890. Hello world, yeah. So this is, this is very, very simple example. Create the HTTP server object, set the port. This is basically Indy, right? So you set the port on server requests. Okay, this is the event handler. It's just a standard procedure, just like in Delphi. You get a request object and a response object. And in this case, we just write out, we got a request, blah, 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 and you ship back some HTML text. In a real live server, you would have, it would look up the file system, search for an index file or something like that, or build a directory, and then just ship that back. So yeah, so here you see it's running in Node. So I've mapped the output, so you get that here. So you see it's sending it back. So this is a very, very simple example, but the power of all of this, even though it probably looks very Spartan to you guys, right? You're used to sitting in Delphi, everything is, you have all this cool wizard and things like that, and this is a little bit more Spartan, but the benefit of it is that the code is extremely fast. It is portable. It is universal. You can run this anywhere. I invested in a smart TV a couple of years ago, which cost a fortune. And it actually has Linux on it. So I can actually take, remote desktop or a remote shell into my television. And I installed Node and I installed, the QTX system. So I actually was able to run the desktop on my television. And I was just sitting there and what have I done? It's like a sort of Frankenstein system. But it was really fun because you can play with this and it works everywhere. And of course it's lovely to be able to, okay, I can write Pascal. That is something that I know well. I don't have to sit and dig for months in JavaScript.
Hi, John.
Hi.
One of the things I liked about this is how easy it is to actually take a Node.js module and actually convert it into Delphi and actually be able to use it within the system. I think that's one of the powers of Delphi, is actually being able to create your own components. It's very, very simple.
Yeah, exactly. So it can be a little bit daunting, at first, but once you sort of understand the basic principles, of the mapping of these, class names and objects, and using, the variant data type as a sort of a bridge between those, between the Pascal world and the JavaScript world, you can do some pretty cool stuff. So, but it can take a little bit of adjustment, just a little period of confusion in the beginning. But that's true for everything. I mean, if you jump in and you want to learn C#, for example, there's a whole new world of terms you have to learn. So in that case, I think we're doing pretty well. There's only like 10 things maybe that you have to sort of look up and dig into.
John, we're back again here. We're a bit overheated, but we're in the whole meeting outside. We're pretty close to just sitting in the car park.
Yeah, well, it's pretty cold here, so I don't have a problem.
I don't know if
this is, I figured I could show you this. This is a, you probably heard of the project called DOSBox, which is essentially a DOS implementation, a DOS emulator, or whatever you want to call it, that allows you to run DOS applications. And somebody took that and converted it from C code into WebAssembly. So you can now actually run DOS applications in the browser quite easily. So I just set up like a tiny project. So let's start that. Now it runs DOS, as you see, and then it fires up. This is an old game. That was one of my favorite games as a kid. Sort of Indiana Jones click and point game. Of course, the only point of doing this is to see, sort of explore possibilities. I mean, if it can run this, could it run something else? Could this be useful in some way? It's actually quite ironic that half of Norway are still using a shop program, a sales program that is still running on DOS. It is so popular, and everybody loves it. They refuse to change it. So you see these monster PCs running DOS, and the system works really well. It's probably 30 years old now. So they could then use that in the browser, and a company could take this technology and then say, hey, we can provide hosting, and then you can simply need a browser. Now I haven't mapped up the set capture here, so you have to do this like that. It's a little bit tricky, but yeah, you get the idea. So it is the full game, and you can actually play it. We can actually open it up in the browser. I'm using this is the Chromium embedded project for Delphi. So it's running it in its own Chromium context there. Oops, that was wrong. Why didn't that work? Copy. There we go. I'm just going to leave this open so that we have the server running. Oh, that was pause. Let's see if we can get it going. Yeah, it's a little bit of flashback, but it's always fun to sort of experiment a little bit with technology. There is also an x86 emulation. So there was a guy that actually booted up Windows. I had to try it myself, and it actually works. You can actually boot up Windows in your browser. It's of course extremely slow, but it is possible. So sort of.
10.
Which version of Windows, John?
What?
Oh, which version of Windows were you talking about? Were you running it?
Windows? That was, yeah, Windows 7. The original project was Windows 95, so it's kind of useless. But yeah, it was Windows 7 that I tested.
Yeah, that's pretty cool.
Audio is, I can hardly hear you sometimes.
Okay. All right, so guys, we'll have to speak up if we've got a question. Is that any better, John?
Yeah, that's much better. Yeah, thank you.
So yeah, I got a question for you. So just how, if you press the back button on the browser, you got a Quartex application running. If you press back, does the Quartex application know about that, or can it handle that?
Yeah. There is a standard event in the document object model on navigate, and that also has a cancel parameter. But for security reasons, the browser has pretty rigid security. You have to have a dialogue that sort of pops up and asks the user. There's a couple of rules there. So, but yeah, you can notice it. Everything that is available to JavaScript in general is available to a QTX application. You have full access, so you can choose to work directly with it. You can also mix and match JavaScript directly in the code. For example, let's say I want a little JavaScript snippet right here. I can just do asm console log. You know, this uses the console object, so I can write normal JavaScript there.
Isn't it the assembler? Yeah.
So we just sort of recycled, you know, the asm block. So you will find in the RTL that there are a few JavaScript snippets here and there to sort of get things working. Also, data typing. This is, I think I spent probably a week on this this class right here. It looks really simple, but in JavaScript, everything is variant. You know, the variant data type. So it gets its data type the moment you assign something to it. Then they introduced proper, you know, typed variables. So you can have like an int8 or byte ri, for example. And so I started to, you know, set up, try to make the fastest conversion routines that I could. And they're really fast as well. Then you have like normal binary Delphi streams are then on top of this system again, and so you aggregate up functionality. But I think we covered pretty much everything that you would need. There's always something that you could add, but yeah. Here, for example, you see a small asm snippet. This simply checks if the application is running under Node.js. So that is a sort of a helper function to, okay, is this code running on Node.js or am I in the browser? So it's, you will find a few of these snippets here and there. Write line maps to the console log method in JavaScript. So because all of this is converted to JavaScript, so there really isn't any distinction. It's just sort of a mental distinction between, you know, you write Pascal and you get JavaScript. But I'm gonna switch over to another virtual machine. I'm gonna show you the service system. So when you want to run a Node.js application as a system service, so that you know, so that it starts along with Windows, for example, just like a normal system service, you have to use a process manager because Node.js is extremely sensible, I guess you can call it, or sensitive, I guess is the word. So if there's an exception that you haven't handled, the security rule is that, okay, then the entire script is aborted. You know, it stops, and that can be an issue. So in order to, you know, get these processes running when you boot up Windows, and also to have, you know, a fault tolerance, so that if an exception should happen that you haven't thought about, the application goes down, and then you have the process manager that simply brings it up again immediately. And then you can set rules like, for example, okay, if this goes down more than 5 times, then send an email, you know, normal administrative stuff. And that system is called PM2, which is Process Manager version 2. And that is a free tool that you install using the Node Package Manager. So when you install Node.js, you also get the Node Package Manager automatically. And you can use that from the shell, simply npm, and then the package you want to install or uninstall or list or whatever. And when you install a package, it's important that you go into the application where the folder is, because npm will install into whatever folder you're actually in. So if your application uses the WebSocket module, for example, you would then cd into your project, npm install ws, it downloads everything it needs, it recompiles it, and you're ready to go. But npm is, or PM2 is actually more or less standard. You can Google PM2. There's a lot of documentation on it, and you get stuff like this. So here I have the 3 core services for the desktop. So you can see the processes. You can do stuff like let's see, PM2 reload all, for example. If I've done some changes to the code and I want, everything to start up again. And it starts up the services, installs. The window down here is just a separate shell window, and then I've typed PM2 logs, and that shows a sort of a running log of all the processes. So let's just reload the web application, and now we're logging into the desktop system. And you have a live sort of output on the side here. So the Photopea link here is, this is just using the normal Photopea external application. It's not something that I've bundled with my system. I tried to create sort of a back route so that we could get rid of some of there's a lot of advertising on it. So that's why you have a second one called Photopea crack, but it isn't really crack. It's just try to get that frame away. So this works, just like normal. It's basically a Photoshop clone. Although I can't actually say that I have used it that much, but yeah. There we go. I have no clue what I'm doing right now, but yeah, it's a Photoshop clone. I'm sure some graphic artists will know how to use this properly. And this is running in its own frame, like I mentioned. That is sort of the key here. So the code that's running inside this window has absolutely no power over what's running outside. The only way this application can talk to the desktop is by sending messages. So when I start an application, I create a sort of message object that is shipped over to that frame. And that is the only way that that frame can communicate. And then there's a standard protocol for how you would invoke, standard methods in the soft kernel, I guess you can call it. For example, if we start the LDEF assembler, here we go. When I click open here, this dialog is not a part of that application. What happened when I click open was that a message was sent to the desktop. Please open up, a modal dialog for files, showing the file system, allowing the user then to pick a file. So you have sort of this, sort of proxying between the code that's running inside a window and what happens outside. And depending on the security context, which is a JSON file, pretty much the same system that Android uses. Depending on, the security, you would either be denied opening up a dialog or direct file access. The program can't just, wreak havoc on your file system. It has to ask permission first. So yeah. So here we have, modal dialogues, and you can pick a file, but I don't have any assembler files right here now. This is the assembler stuff I showed you earlier during the slides. It's based on the 68K, but there really is no limit. It's a very fast system. The code runs, almost as fast as WebAssembly. There's some scaffolding in order to support things like variables and variable IDs and things like that. But yeah, so we can assemble the code, and then we can list out the bytecodes. Here is the sort of machine code that is generated. And we can disassemble it. Same code, except that you see that the jump offsets has been calculated. And we can run it. And then it left 4 and 16 on the stack, which was the point. So yeah, there are a few options there. You can see if we can get Tyrian. I think I had Quake here somewhere. So the point of this was basically to see, okay, how good performance can we get? JavaScript, WebAssembly, how much speed can we get on the lowest possible hardware? So I tried with a standard Raspberry Pi 3B, that was too weak. It could barely open up the display. It couldn't start Quake, none of that. It was simply too low spec. I then went up one notch to Odroid XU4, costs roughly $10 more. That was able to drive the whole system brilliantly. You don't get 60 frames per second on an Odroid XU4. Then I went up one step to Odroid N2. That's a little bit more expensive. That's roughly $100. I think it's cheaper now, but roughly $100. And that was just a monster. You know, if you can run the desktop, the background services, it would run you know, full screen Quake at 60 frames, and so that's a good aim to go for if you're making embedded systems. So for example, let's take an example for this one. Let's say you were asked by a company to create a kiosk system. They want you know, touch screen, being able to click around, like for example, one of those map boxes that are in malls in America, which cost a fortune to maintain. Okay, you're asked to create this. It has to work over the network. Any update should automatically spread to all the units. You can then use this system quite easily to create that type of display. You would simply, you know, disable the disk stuff, disable the menu stuff, disable it's a normal INI file to control these things. And then you will simply set the desktop to load your, you know, touchscreen fancy interface thing. And then you have access to a file system, you have network, you have security, all of it out of the box. You can also pick another theme instead of going with, you know, the blue kind of childish windowing system. You can go for something a little bit more modern, put it in full screen. So there's a lot of options, a lot of money that can be saved as well. I actually investigated. It was a company in Norway that is providing these kiosk systems for the Norwegian government. So all the town halls, they have to have one of those kiosk systems at the entrance. So if you have an appointment, you have to click, okay, I have arrived, blah, blah, blah. It turned out one of those boxes costs roughly $5,000 to rent every month. And they're using native code. I'm not sure if it's Delphi, but it is a native system that is written in, and they're using an Intel i5 board. So the cost is quite high. You could pretty much easily replicate that system using a Raspberry Pi 4, for example, which is more powerful than the 3B, costing $40. And then you fork this system and adapt it. So there is a good opportunity to create some good business with this system as well, because it saves you the time. You don't have to sit down, oh, I have to write a file system. Oh, I have to write a security system. Oh, I have to do this and do that. And I have to deal with security context. You don't have to do that. You can just start QTX, create a new desktop project. QTX clones out all these background services for you. And your job is essentially just to make the changes to the desktop as you see fit, removing things, adding things. And then you can sit down and create the application that should run inside the window or full screen. That's, I think that's a pretty good, a pretty powerful system if the right people use them. But do feel free to ask some question. I'm sort of just babbling here. so if anybody has something to that they want to look at, or
yeah, I'd like to maybe start some questions from everyone about just a bit about the history and your experience. Anything interesting that you came across, anything that you found particularly difficult. So just looking at. Some of the things that we're more familiar with Delphi. You've actually built an IDE basically very much like Delphi. Did you start that from scratch, or did you have something to base it on?
It's very difficult to hear what was said.
All right, I'll just try that again. Is that any better?
Yeah, that's better.
Okay, so you built your IDE, which is very Delphi-like, so it's good for us. So, did you start that from scratch, or did you have something else to base it on when you created the IDE itself?
No, this is we started from scratch. Well, I guess it's impossible to explain it without taking some context. The desktop system that I just showed you here was initially created in Smart Mobile Studio. This was a hobby project that I had on the side. I mentioned earlier, I wanted to, is it possible to extract some of these technologies from the old Amiga system, to learn from them and clustering and all of that? And we came to a point where Smart Mobile Studio simply didn't have the stuff that we needed. And I'm not saying that, to sort of pick on Smart Mobile Studio. I loved what we did with Smart Mobile Studio, and I put 10 years into that company. So yeah, that was it was pretty hard to leave back then, but we came to the conclusion that the vision we had for the system simply wasn't compatible. And I had invested all that time and code into building this, and we came to a point where simply there was too much missing, and I didn't have control over the product. I couldn't go in, for example, if I found something that was wrong with that system, I couldn't go in and fix it and then simply commit to fix, because that was the alternative, that I would sit and basically build up the rest of Smart Mobile Studio for free. So it was quite an intolerable situation. And then I took it up with the backers and simply said that I think that we need to roll our own. We have to stop and simply look at what do we need, what can we do better, and start from scratch. So I started on the IDE, and I spent a long time building up, over a year, building up the runtime library, the RTL. And I had to do everything differently. I wanted to avoid some of the pitfalls, some of the things that was really difficult and that we struggled with the older program model, I guess we can call it. Yeah, so I had to start from scratch. So I've been sort of hopscotching between doing this, doing the desktop stuff and the services, and doing the IDE and RTL, and it's sort of been going in circles between those two for a while. And that's the only way I knew how to sort of be able to finish this. But yeah, so everything is done from scratch.
Jon, how long have you been working on it? Like, when did you first start writing code for this project?
Well, the IDE and the runtime library, I guess it's fair to say that we spent 1.5 years perhaps on those two specific. If you factor in the desktop and the background services, then we're talking closer to 3 years. So
it's taken you it's taken you 3 years to knock this out.
Yeah, roughly. If you include the desktop, then yes, yeah.
Oh, that's pretty good.
Just as a fun project, would you ever consider rebuilding the Quartex IDE in Quartex instead of Delphi?
That's
it's a bit of a challenge there for you overnight.
No, that's actually the next step. So this is just an intermediate step. The goal is to have the desktop functional enough so that it can host modern applications. Like I said, the goal is to do for web applications what Windows did for native applications, to create a full infrastructure. And then we can move this as well onto the desktop. Yeah, so we can compile the compiler. It will compile itself. So it's quite difficult to get sort of singularity when the compiler can compile itself, and but then you have the benefit that you can have a school, for example, and I'm a bit passionate about schools in India because they have so few resources. They can't afford a laptop for the kids, but they can afford a Raspberry Pi, for example, and you can have a situation where the kids can have a Raspberry Pi, they can open up a web browser, and they will have the full development system, all the tools that they need to build applications directly available in the browser. They don't need to have like a rough and tough computer to do the building. All of that can be clustered and put on the mainframe, so to speak. So you can have, that was one of the cubes that I showed earlier. This one, for example, I'm switching out a couple of parts. I don't know if you guys can see this. It might be eaten up by the fake background here. But yeah, but one of those is more than capable of providing a school in India, for example, or a full class, the processing power that they need to write applications, compile them, and run them directly. And since everything is happening in the browser today, I mean, the browser is where things happen, right? Kids that learn to program today, they go for the browser. So,
hey,
yeah.
John, the cube that you held up, which I think we saw before, is that Raspberry Pi based?
No, that is Odroid XU4. So it's similar to the Raspberry Pi. It's a little bit more powerful. And then I have an Odroid N2, which is slightly more powerful. Again, actually, it's very much more powerful. And that is used to sort of render the display. So when I boot up that cube, I can then plug in the HDMI to a monitor to the N2, and then I get the desktop display, and I can use that entire cube then as a single computer if I like, but it also acts as a server. So you can sit with a different computer and then connect into that, log in, you can have an account there, etc., etc. So
and just to clarify the deployment platform. So when you build your application in Quartex Developer, you can then deploy that to pretty much anything, right? Windows, Linux, Mac, Arduino, all over the place. So how would you define that target? It's anything that can run Node.js. Is that correct?
Yeah. Anything, if it can host Node.js, you can run service application. If it has a browser, you can run the visual applications.
And we're really talking about, essentially it comes down to you're writing code that's very Delphi-like, but it's generating JavaScript code that then gets deployed to Node.js. So you can have it'll either have JavaScript code that's running on the Node.js server or in the browser on the front end. Is that correct? Yeah.
And then you can, those two parts can then talk to each other using, standard protocols. So I can show you some of the
I've got a question for you. You said earlier that you were using C++. Now, why would you use that instead of Delphi when so much of the rest of it is sort of Delphi orientated? Where was it an advantage for you to use the C++?
In what context?
Well, you said you were using C++.
No, it was. I had 1 year I was using C#, but when I converted, there was a project that was written in C, and then you can compile that to JavaScript or WebAssembly, and then you have to use the Clang or the C-Lang. I'm not sure how you pronounce it, compiler. I've used some C and C++, basically because of speed. There's no denying that. The C language, the C compilers have. They have a ton of developers that are purely working on optimization, for example. So it's probably not popular, but C code generally operates faster because of the amount of resources they've spent. But I don't sit daily writing C code. It's just the average snippet if I needed a library, for example, something like that. So I spend 90% of my time in Delphi or QTX.
John, just regarding touching on licensing. So I'm aware of, you know, like the beta program and the fee involved in that. Do you want to just explain that for the audience?
Yeah, the way that we've had found a way to fund this is that it touches on two technologies, right? I mentioned, you know, the Amiga legacy stuff, and also the Delphi community is interested. So you sort of have two different communities that have sort of helped fund this, and we've only gone through word of mouth in the Delphi developer group and some of the Amiga groups. That if somebody wants to help out, if somebody wants to help back this, then we have like a standard donation of $100, and then you get access to the admin group. We have a sort of a hidden group on Facebook. And then we try to do weekly builds. Sometimes it can take 2 weeks between every time we sort of ship up a new binary. We also have hosting on Bitbucket, so that if you're part of the group, you can go in and look at the code, and you can fork the code, and you can play around with it as much as you like. So that's how we're funding it. When it comes to licensing for using it, I want this to be free for everybody. I don't want this to be something that you have to pay a huge amount for. I want schools to be able to use it for free. People who simply are interested can download it and use it. And then we have a simple clause that if you want to use this in a professional capacity, then please do buy a single lifetime maximum $300 license for it. And that is purely to keep the project live. That money will simply go into bank account, and then we will use that money to fund hours and days of development in the future. So it's not really a financial project for me. It's purely to make the technology a reality, make it easy for Delphi developers to go in and use, tap into the Node.js and the JavaScript world. There's a whole market there that we simply are not a part of. We can't really compete. Hopefully this will make it possible for us to compete with that market.
Do you have anybody helping you? Like, are you like yourself and no one else, or have you got other guys that contribute various functions or ideas or anything?
Well, it's mostly me, but lately a couple of guys on that forum has, I've written a wrapper for this, I've written a wrapper for that, I have a demo of this. I was actually hoping to show the Fishfax demo today, which one of the users made, but unfortunately time sort of ran away from me this morning, so I wasn't able to prepare it. So yeah, they're slowly coming in some contributions with, especially wrapping, these pre-existing libraries. Pretty much, it's almost the same as wrapping a DLL for Delphi, right? If you have like a C++ or C DLL, then you want to make that usable from Delphi. Somebody would write like a wrapper unit. And hopefully people will get a little bit involved in the IDE code as well. More people will always find, solution better than one person sitting in there doing all the stuff. So hopefully we can get some feedback on that as well.
So we're starting to see people. I'm mainly on the Facebook group, where there's like a developers group where John is also part of. So it's interesting. You'll get some conversations on there where people are asking some technical questions, and people are starting. We're starting to see more people get involved and provide responses on that. But a really interesting thing is you'll get a response from John, and you're thinking, this is the guy that wrote the IDE, wrote the compiler, wrote the parser, everything. You're getting a reply from someone that has that level of knowledge. So yeah, that's really good.
And
question, where do we find this stuff online? And what's the URL of your
Well, I probably should have created a website for this. I haven't done that because we have been racing against the clock to sort of get this finished. But it's mostly I post to Delphi Developer. on Facebook. So it's just a matter of just PM me, or I can send. We have like a PayPal thing set up, so people who wants to donate or wants to be part of it, they can just use that and then just PM me, and then Facebook has these strange rules where, for example, I can't just add people to that admin group because it's hidden. I can only add people who are my friend or that I have in my friends list. So that's why you have to PM me, and then I will sort of add you to my friends list, and then I can inject you into that group. So we are looking at see if maybe it's time we move this over to a dedicated host, to have like a proper discussion forum with memberships and access to everything from a singular website. It's sort of been debating that the past couple of days now, if maybe it's time to make it a little bit bigger. Yeah. It's a question of time. I mean, I have a full-time job. This is sort of a weekend operation for me. So yeah. But just contact me on Delphi Developer or send me a personal message, and yeah, that's.
I will send out some information to everyone that I know on here, if I've got your email, with some download instructions, links to a few Facebook groups, just basic things like that. I don't know, John's email. So can I ask everyone? We've got a lot of people on here, and I don't know who you are. If you can just post a comment with your name and email, and then I'll try and get those distributed to you. So yeah, we're getting quite a lot of people in here, 22 people, plus a bunch of people here at the meeting. So for those 22 people that are online, see if you can find the chat option within Zoom, and just yeah, post a comment with your email.
Yeah, I just wanted to mention again that I can't take credit for the actual compiler. Like I mentioned, this system contains 3 compilers. Only one of them is physically written by me. So when we're talking about compilers, that is actually Eric Grange, the maintainer of Delphi WebScript. He's the one that has done all the work there. So yeah. So we worked quite closely for a year on that, but he has sort of continued to maintain that, and yeah, so he deserves the credit for that. I haven't written that part. That is, it is important to mention that. So LDEF is.
Sorry, go ahead.
No, LDEF is the compiler, the bytecode compiler that I'm doing. So eventually that will have its own, Pascal parsing layer on top of it. That will be geared more like in .NET, so that you can have bytecode based modules that you can use in both Delphi and QTX. That is a separate thing. So yeah.
All right, I'm gonna run a couple of speed questions by you. So quick, snappy response. First up is just with the language. What did you find the most difficult thing to build? Pick one thing that you think was the toughest thing.
With the language, well, oh, that's a tricky one. There were so many things that was difficult there. Again, when it comes to syntax, the language, again, that's Eric. We spent a lot of time, sharing ideas and things like that. But I feel that when it comes to language, that's really his table. When it comes to the runtime library and the IDE, and especially the runtime library, the async nature of JavaScript was the most difficult thing to tame. Having to research and find how exactly is it JavaScript optimizes internally. So I had to go through the Node.js and the V8 engine, the C code. So the async system is by far the most mind-bending thing in the system. Yeah.
All right, next one. So with the IDE, you've built an IDE that's heavily influenced by Delphi. Did you find yourself developing any feature that you thought was actually pretty cool and you'd like to see in Delphi or other IDEs?
Oh yeah. I have. I guess I can show you here. This one is quite neat. When I click a class like TMyForm, I can see the entire inheritance chain. So I can go in and then just click, and then I go to that unit. So that is something that I think could be useful in Delphi. I also should mention that most of the language features that Delphi has recently adopted came straight out of the work we did with Delphi WebScript. Inline variables, anonymous precise, all of that stuff is very, very inspired by the work we did. I was hoping that Embarcadero would adopt partial classes, because that solves so much. It would take too long time to show you everything that it solves. But partial classes, I really hope that Embarcadero adopts that, and Free Pascal as well, because it would clean up pretty much the whole LCL. So yeah, partial classes is good, and also being able to easily navigate the inheritance tree.
Do we have any questions from people that are online? We've got 23 people online there. If you have a question, either unmute your mic, or if you've got problems with that, just type in your question, and John should see that.
I've got one. Delphi WebScript or QTX, whichever way it works, except you work with generics?
Well, Eric added support for generics, but it seems to have stopped up a little, because there was a problem with how generic operated. I don't remember exactly the bug, but there was something that caused a little bit of problems there. But initially, generics was planned. But to be honest, the way that Delphi WebScript and operates with arrays, I don't really find myself missing generics. There are a few cases when it comes to sort of if you have elaborate class hierarchies, that generics would be useful. But you have to remember that every array has all the functionality of a T-object list, and then some. So there's a lot of functionality directly in the array object that you would normally sort of find in generics. But I don't find myself missing it, to be perfectly honest. But yeah, I hope that Eric continues and that he finishes that. I really do, because that would be sort of the frosting on the cake. But some of the alternatives that he came up with and that we brainstormed back in the day really remove some of the need for it.
And I'm sorry if this is a tangent question, but I'm interested in, there's some really great libraries in JavaScript, like D3, for data visualization, that sort of thing. So DWS or QTX, they'd work in that way, in together with that?
Yeah, you can use, like I showed on the left side here, you see all the files you have. And if you want to use an external library, for example, you would simply copy that into the project folder. And then, of course, you have to look at the library and see, okay, how is this library initialized? For example, if it's showing some type of graph, there's always a function, that creates that graph, or and then you have to do that in from QTX. Yeah, like I said, you have this ASM. We recycle the ASM keyword.
Right.
So if you have some sort of library, I don't know, create something. And then you have like, so if you need to send in some sort of, parameters or something like that, you can do that. Simple like this. This is enough to, create an instance of something. But ideally, you would sit down and you would look at the JavaScript objects, and you would write a Pascal class that sort of matches the JavaScript object, and then you can reference it by name. So then you can just create the object just like you would a Delphi class. So yeah, that's it can be a little bit tedious, but yeah, you can work with everything that JavaScript has. You have available here, and you can also mix and match. So you can also write directly in JavaScript, like you see here. This is actually a resize observer polyfill. This is actually a library that simply check if your browser is too old. If your browser is old and doesn't have support for something called a resize observer, then this actually injects the resize observer functionality. But you can see you can work with JavaScript files directly. And you can mix and match. And so if you have a function called hello written in JavaScript here, you can then call that from an Asm snippet. So it's quite easy once you get into how you invoke JavaScript methods, how you map up a Pascal class to a JavaScript class. It's pretty straightforward. It's not complicated at all. It looks far more complicated than it actually is.
How's documentation?
Documentation has been started on. I made myself a promise that I was going to document while I was developing, which I haven't been able to do. But that is something that I really want, because that is something that was missing from the other product we had. We had really good documentation has to be there really. So I've started with the basic outlines. Like I tell everybody that comes into the group and wants to learn that, go through the documentation. It will save you so much time, because here we look at the differences in language, property expression, RA operations, like you see here, lambdas, partial classes, things that you really have to know in order to use this in a good way. I mean, partial classes essentially means that you can have the same class in different units, and the compiler will take that and glue it together during compile time into a single class. So you can spread the implementation out over different units. I mentioned Free Pascal earlier. For example, if Free Pascal would add support for partial classes, it would simply have a core class, and then it will have like the Linux version here, the Windows version there, and the Mac version there, for example. And it will all be neatly organized instead of having a bunch of include files, which Free Pascal sadly uses. But that's just an example of how you can use it. So the RTL uses that quite extensively. The application model, for example, is all partial classes. So it's there are a few things that you have to sit down and spend 5 minutes reading about. So we have started. I think we have covered most of the standard stuff. But I have to go over it and fill out all the rest, because there's a good 6 months since I started the documentation now. So we need to follow up on that. Yeah. I'm also going to shift the swap out the viewer we're using. I think this is an older one, Gnostis PDF or something like that. And now we have the wonderful HTML components, which is able to read PDF files and convert that to HTML, so we can use that instead, which is much faster. So that'll be good.
That documentation, is that readable to people who haven't contributed just yet?
Oh yeah. It's well, the thing is that the whole project is kind of behind that hidden group right now, but there's not much. I mean, we don't have a hidden group because it's supposed to be a secret. That was the only way to avoid having to go into like using a system like GoFundMe or one of those websites, because that suddenly brings in a whole bunch of taxes and blah 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 and invoicing, and there's just too much paperwork for something that should be simple. So we just use this. But I have no problem building like a preview version or something like that we can put in Delphi Developer so everybody can, give it a spin. We've talked about that before. I haven't done it because we kind of wanted to have that in the group, sort of an incentive for supporting it, that you would get, weekly updates. You have full access to me, you have full access to, there's a small community there now that discuss how to do things, and if somebody has a problem, we help him or her, so. But yeah, just let me know and I can ship over the PDF. The documentation is in PDF format, and we can also, I guess we can do like a preview build for those who want to, to test it. But it's still very early, just so you don't expect, Delphi like functionality everywhere there. That's we're not close to that yet.
I've got a wee question, John. How cold does it get up the far north of Norway in the middle of winter? What is that? Is that minus 30 or something silly, or what's that?
Yeah, minus 30 is typical for a relatively short period of time, thank God. We have, there are changes to the environment up here as well. So it has actually gotten a lot warmer in the region that I live. So we do feel, we do, experience some changes to the environment up here. But yeah, when they come up north, on the borders of Russia, minus 30, minus 50, although I think minus 50 is very rare. But there are parts of that region that has minus 47 or something like that. It's almost 50. It's yeah, I'm glad I live in the south.
Who lives in Norway? He's got 2 or 3 houses there, and one of them is right on a river, and on the other side of the river is Russia.
Yeah.
Yeah. And he's been across the river and stood on Russian soil and had a pee and all that stuff.
It was fun. It was fun. It was fun living here during the Cold War. That was heart-wrecking. Constantly, I mean, you can remember, being a kid in the 1980s and growing up in Norway, you're like the first target. We actually did a calculation. I think Norway would be able to withstand Russia for the whole of 3 minutes. Then it's game over. So yeah, we're very happy that the Americans built some bases here. Yeah.
Thank you for that, sir. Well, you've accomplished some pretty techo stuff here. Well done.
Thank you. Thank you.
Very well done.
Yeah, well, I hope to at least, I hope to create something that is useful for the community. I was really banking on Embarcadero doing something like this. Do you guys remember there was something called, what was it, Delphi for HTML5 builder, or Delphi for the web or something like that? And this must be 15 years ago or something.
Yeah, that was basically PHP. When you looked under the covers, it was PHP. Yeah.
And I was completely gutted when that happened, because everybody thought that, oh yeah, we're gonna get Delphi, so you can type Delphi and you get JavaScript, and everybody was really excited about that. And then it came out and it was what, PHP, and then they had like sort of a VCL like interface. I remember that was just tragic. So I was really hoping that Embarcadero would like resurrect that system. Okay, let's take the old Delphi interface and rip out the PHP stuff and get Node in there. And yeah, I was really hoping that. So when I started at Embarcadero, they talked about that it might be possible that I could do something like that for them, but it never materialized. So that was a bit annoying. But yeah, I think Delphi really needs, or the Delphi community needs some good web tools. Sort of, you can't really show up to modern, like customers come along and say, oh, I want a mobile application, I want this, I want that, I want integration with so and so, and you're sitting there and your only options are, oh, I can do native applications for Windows, that's it, or Mac OS. That's it's not enough. We need more instruments to play on, and hopefully this can be a good instrument for people. So yeah.
Hey John, so keep in mind, we're sitting here at a Delphi meeting, and we're very used to the forms development. So visual development, dropping a button on a form and so on. Do you plan to add a screen designer, like a? I know you've got the one there, but can you actually drop controls on there, like buttons and?
No, that's coming. This has sort of been put on pause while I was doing the windowing system, because all of this, a form will map up to a window. So it makes sense to sort of make sure that the window code was there first. so I put this on pause, but yeah, this will be there. So and then you have components all the way over here. We have had a little debate on instead of having all this, screen real estate, just collecting dust, that we actually move the component bar up here. So you get it here, so then you can just drag and drop like you're used to. We've also expanded it a little bit because the Delphi way of doing things is very efficient when you're on Windows in a native application. I don't think anything is as productive as Delphi. Delphi is unbeatable when it comes to window applications. But when it comes to web applications, there was a few things that we could add. And the first thing was to separate a design from a form. So that when you design something here, that is called a view. And then you can take that view and you can assign that view to whatever you like. And that's going to save a lot of time because these things can be recursive. You can have a full design and you can put that into a button if you like, which in turn can have a view, and so on. So it's recursive. So you can do a cool layout here. You can assign that then to a form, or you can assign it to a panel or any container. So we've sort of expanded, the form design philosophy a little bit. And you can also switch between normal design like this, drag and drop layout. And when you click that one, it's going to animate, and then you get a blocking view instead, like I mentioned, which stretches to 100%. So you can create sort of dynamic layouts. So yeah, this is coming, and this is I realize that most Delphi developers will feel more at home here, and I think we're just going to make it as homey as possible. And for those who wants to dig into like the view stuff and want to use that with the new and fancy functions, they can do that. But if you just want to, okay, I want to work like I do in Delphi, then that should be possible. So yeah, that is coming. I was working like hell to try to get this coupled up with the code last week, but we had too much to do at work, so I didn't have time for it. I was hoping to have something to show you there.
So you're doing all this on a part-time basis then?
Yeah, it's mainly weekends and after work. So I have a full-time job on the side, and 2 kids and a cat and the whole 9 yards.
Bearing in mind that I think it's being recorded, would you like to say anything about where you think Embarcadero's heading in the next couple of years?
Well, I am a free agent, so no, I actually I'm very fond of Embarcadero. I think that Borland built up a lot of loyalty, and Embarcadero has inherited it. I was very critical to begin with, and when I was offered the job there, I was sort of what me? I've sort of been a huge critic for a while, but when I got to see, behind the scenes and how much work these people do, and some of the complaints that they get, and people really, yeah, it's. I had to sort of bite the bullet and apologize for being such a harsh critic. They're doing the best that they can. It's not easy because American companies are extremely organized, right? You're only supposed to talk to your manager, who then takes your case further. It's very rigid, very strict. And Embarcadero represents just one layer of management. You also have a second layer from Idera. So that there's a lot of stuff that the people at Embarcadero want to do, and they're sort of biting their hand because they don't. They're not always allowed to do that. So they get a lot of negativity, which really isn't warranted because it's not something that they can decide. That's upper management in Idera that deals with. And Idera is a database company to begin with. To be perfectly honest, I'm not sure that they really understood what they got when they bought Delphi. I heard one of the managers once refer to Delphi as a Fox Pro clone. And I was like, what? Thankfully, that person is no longer in management, but yeah, I think they viewed Delphi purely from a database kind of viewpoint. And then the management at Embarcadero has done, I think they've done an amazing job in bringing Delphi up to speed. I mean, when they took over, most people were on like Delphi 7 and Delphi 2006 or something like that. A lot of people are still using Delphi 7. It's quite amazing. And then they sort of had to get rid of all the old stuff and then rebuild all the way up to Delphi 2010. Delphi 10. Delphi version 10 is sort of the foundation now, I think, and I think it's a good foundation. And I can probably list 100 things that I would do differently. It took me like 8 years to lobby so that we would get that XML mapper updated. Same also with Bold for Delphi. Not just me, but also others had to do quite a bit of lobbying in order to get them to open source it and get that into the MVP branch so that it could be updated. It should have been updated ages ago. But how Embarcadero is going to look in a couple of years, I don't know. I have no clue. I hope they continue, and I hope that they realize what they have in Delphi, and that Idera allows Embarcadero to do more. There's nothing.
Questions from the audience? Anything you'd like to raise before we? We don't have to call it quits there if you got other things to show us, but.
No, I think we've covered most of it. It's actually, we started at 11, so now it's 1 o'clock here. So yeah, I think we've got a good run.
All right, well, I'd like to thank you very much. It's been really interesting. And as I mentioned before, I've actually been using Quartex, just dipping my toe in the water the last few months. And yeah, personally, I've been telling you, it's been a really good experience. And it's been great being on the Facebook groups and getting support with a lot of other people, having yourself getting involved in that as well. Yeah, it's been really interesting. So appreciate your work. Thank you.
Yeah, thank you so much. That's nice to hear. And I hope we will be able to come up with a complete solution that everybody can find useful and that they can use in their work. Yeah.
We just had a question pop up about whether it's being recorded. I'll try and make it distributed to everyone. Add a comment, put your email in the comments. So in the Zoom chat option, just list your name and your email, and I'll trawl through that and I'll get it up on YouTube or send it to John or something like that. So yeah, just make sure you add a comment with your email. When you join Zoom, I don't know who you are. I've just got a name there, but I don't have a name or email for a lot of people. So yeah, just add a comment with your email. Okay, so John, thank you very much. I'm going to leave the Zoom meeting open for a little bit just to give people time to add their emails, and we'll close it down in a few minutes. So yeah, appreciate your time. Thank you very much.
Yeah, thanks, John.
Thanks, John.